Hi everybody, good morning. So today we will go over the quiz solution and quiz mistakes, and we also will talk about one problem on the practice exams. And when is our exam? Friday. It's for you today. So today I have a class here. So they also have exam from 11 to 12:30. So if you finish your class, come here because I might not be in my office. I may be still here. Yeah. Okay. So yeah, Friday, and try to come here as soon as possible. If you come early, you can like start the exam early. But if because I have another class after this in the same room, so if you need more time after class, you can feel free to stay longer. And when you finish, just turn in your exam and then leave on Friday. Okay, everybody. So let's see. Okay, so the quiz. This problem, we were talking about using the limit definition to find the derivative, right? So this is the formula. By the way, in the exam, I won't give you the formula, but you draw the points. Remember, the first point you call it x, the second point you call it x plus h, then the y coordinate will be f of x and f of x plus h. And then your slope is change of y over change of x. That's why f of x plus h minus f of x all over h. I think all of you get this right. So we plug in x equals x plus h. But the next step, when you expand, many of you make the mistake. X plus h squared. It's not just x squared plus h squared. You have the middle term 2xh. Everybody say middle term. Middle term. Yes. So make sure you remember this part. And here, when you plug in, you need a parentheses. So when you distribute, you actually get minus 3x and then minus 3h. And then here, also you distribute, you change all the sign. So this negative 2x squared minus become positive 3x minus, and times 1 is minus 1. And then you realize the 3x, negative 3x cancel. The 1 and the minus 1 cancel. And then the 2 here, we also need to distribute. So 2x squared plus 4xh plus 2h squared. And the 2x squared also we can cancel with the 2x squared. And then always the case, you can see all the terms on the numerator have a common factor h. That's always the case. If you cancel, you realize there are some terms without h, that means there's a mistake. Then you go back and fix your work. Maybe you forget the parentheses. Maybe when you distribute, you forget to change the sign. Okay? So hopefully no terms, all the terms left with h. Okay? Alright. So that's why we can factor out the h and cancel with the factor. Right? So we got 4x plus 2h minus 3, and we let h go to 0. So the answer is 4x minus 3. Okay, everybody? And part B, use the derivative rule, which is the power rule we learned last time. See? The derivative, constant multiple. What's the problem again? Constant multiple. The 2 stay here. And then the derivative of x squared is you move the exponent down in front, and then x to the 2 minus 1 is 1. Right? Minus 3. And remember, when you take the derivative, your power drops down by 1. So x, the power is 1. When you drop down by 1, you get the power is 0. Anything to the 0 is 1. So you get the constant term. That's why when you see a linear term, when you take the derivative, you only get a constant, which is the coefficient of x. That's why you get 4x minus 3. Do you see the answer match?
Yeah.
Yeah, so no matter you use the limit definition or you use the power rule, the answer should match. Okay, in exam 1, you're required to use the limit definition. Okay, so do not use the power. You see power rule very quickly, right? But really how it works, why we can have the power rules, because we prove it using the limit definition. That's why we can use it. So exam 2, 3, 4, and final, you can use the power rule. Okay, it's just exam 1, you need to know this method. Okay, and part C, I asked you to find a normal line, but if you answer the tangent line, I didn't take off any points. Okay, so tangent line is tangent to the curve at that point. So normal line is perpendicular to the tangent line at that point. So this is the normal line. Okay? And do you remember if two lines are parallel? I mean M1 equals M2. They have the same slope. Okay, everybody? And two lines are perpendicular. If their slope, the product of the slope is -1. So that means M2 is the negative reciprocal of M1. Okay, so this is the rule. So if you find tangent line, I didn't pick up any points because I think you're not familiar with the normal line. So tangent line, then the slope is you plug in 4, the x is 4, into the derivative. So 4 times 4 minus 3 is 13. This is the slope of the tangent line. And remember, in order to write a line, you need a point on the line. You also need the slope. The point on the line, we know the x coordinate is 4. To find the y coordinates, you plug in 4 to the function. Right, everybody? So you plug in 4, so 2 times 4 squared minus 3 times 4 plus 1, and you get 21. So the point is 4 comma 21. And then you use the, so points of 4, y minus the y coordinate of the point, 21, equals the slope, 13, times x minus the x coordinate of the point, which is 4. Okay? And then you can distribute the 13, and you move the 21 to the other side, you add 21, so you get y equals 13x minus 31. This is the tangent line. In the exam, I only ask you the tangent line. I won't ask you the normal line. I mean, for exam 1. Okay, exam 2, I can ask you this. Okay. So normal line, if we're looking for, it will be negative reciprocal. So negative 1/13.
Will that only change the gradient?
Huh?
Will that only change the gradient?
Great.
Slope?
The slope, yes. That will only change the slope. And they're passing through the same point. That's why your y coordinate remain the same. Only your slope becomes negative reciprocal, and your x coordinates remain the same of the points. And then you distribute, and you add 21, so you get this answer. This is the normal line. Is that okay, everybody? Mm-hmm. Okay, good. So that is the quiz. Let's look at the mistakes together. Let's see. Yes.
Yeah, there's something wrong with number 10.
Something wrong with number 10 of your homework? Oh, okay. So how about let's finish the quiz mistake, then we'll look at the homework. Okay. So here the mistake is the middle term is 4xh. And oh sorry, the middle term is 2xh, but when you multiply the 2, it becomes 4. Okay, everybody? And here, parentheses, the minus 3 is outside of the parentheses x plus h. That's why this becomes, when you distribute, it becomes minus 3h. And that's why this 4x, after you cancel the h, you get 4x left. And that's why this negative 3h, after you cancel the h, you get negative 3. Okay, so the answer for part A and part B should be the same. If you, actually in the exam, you can use the power rule to check your work. Because if you get the answer here the same with that, that means you're doing good. But if you see those are different, you probably miss a minus sign or something. Okay, are you ready? You can use the power rule to check your answers. And then, yeah, 4 times 4 is 60, minus 3 is 13. So, yeah, so this is the 10th one. But because of that, yeah, small mistake. And here, oh, yes, the middle term. Everybody say middle term. Middle term. Okay, so you multiply by 2, you get 4xh. And do you see the 3h? No 3h can cancel this. So 3x and 3x cancel. 1 and minus 1 cancel. But the 3h still here. Okay, so we cannot cancel it. And then part C, you find the slope. Then you need to find the y coordinates of the points. And then use the point slope form. Okay, everybody? So continue. And let's see here. Oh, derivative. This is good. And then the derivative of 3 minus 3x is negative 3 times 1. The derivative of 1 is 0. Okay, so take the derivative for all the terms. Okay, not just the first term. All the terms you take derivative. Okay? Yeah, so you see the answer here and here should be the same. And then, so f of 4, you will get 21. Okay, that's the y coordinate. Then you use the slope and the point to find the point slope form. Okay, you get a line. So not a number, a line. Okay, it has x and y in it, a line. And then here, oh, the y coordinate is correct, but then the x the slope is 13, so not 4. Okay, 4 is the x coordinate. The slope is you actually need to plug in 4 in the derivative to find the slope. Okay, everybody, so you're good. Minus reciprocal, you know that. Very good. Okay, and then here, so your paper, if you write tiny, make sure you check carefully. Because you see, this guy is the 2x plus h squared. And then you actually miss the minus 3x and minus 3h. That's why you didn't cancel that. Yeah, so missing this. And so this is the 3x cancel. You actually have negative 3h. Is that okay, everybody? And here, the derivative you plug in x is 4. 13 is the slope, okay? Don't plug in your slope in the derivative again, because what are you doing? So let's say 4 is here, 21 is here. This is the point. And you already get the slope is 13. But when you plug in x is 13, you're talking about another point. You're talking about another point, not the same point with this. Okay, everybody? So don't plug this is the slope. Don't plug the slope at the derivative again. Because this means when x is 13, you find your function. We're not looking for the tangent line at this point. We're looking at the tangent line at this point. So draw the picture, then you can understand what is going on. Like we have the point here, and the slope is here, so we can find the tangent line. Okay. So yes, and then here, yeah, the slope is good, and this is also good. Then you use point slope form. Okay, so close. This is the good slope. It's not y. It's the slope. It's the m. Okay, everybody? Not the y. This is the y. The function is the y. But the function derivative is the slope. Okay, everybody? And next. Okay. Yeah, middle term. Everybody say middle term. Yes. So I hope it's okay to make mistake in the quiz. I hope on your exams you will remember this and don't make the same errors again. And yeah, here points of form. That's the y coordinates. And then find the slope and then use points of form. Okay, I think that's it. Any questions about the quiz? Okay, you said homework.
No, not homework. Practice.
Oh, practice exam. Oh, okay. So practice exam number 10. Oh, actually, I had a mistake. So, yeah, thanks, Dylan. I have a mistake here. So 5 times 9 is 45 plus 9, 54, minus 4 is 50. So, yeah, the problem 10 is like the quiz, right? We use the limit definition to find the derivative. You can use the power rule to check your answer. Remember power rule? What do? 5 times the derivative of x squared is 2x. Derivative of 3x is 3. Derivative of minus 4 is 0. See? You get 10x plus 3. Okay, everybody? And your slope. Slope is you plug in x is 3 to this function, right? So we get slope is 33. And the tangent line, you find the y coordinate is 50. Then you can use the Poisson form. Y minus the y coordinates equals the slope times x minus the x coordinates. And then you solve for y. Okay, everybody? And I also want to talk about the true or false problems. Okay, so part A. Suppose f is an odd function. Well, remember, odd function is symmetric with respect to the origin. And even function is symmetric with respect to the y-axis. Okay, so this is the odd function. And the limit when x goes to 3, so this is what it means. This is 3. When x goes to 3 from the right, do you see from the right? My y goes to 4. This is what it means. Is that okay, everybody? Do we know the function value at 3? We don't know. We only know the right side of the limit. Do we know what happens on the left side? We don't know either. But we know when we approach 3 from the right, my y goes to the 4. Okay, maybe it goes like this, maybe it goes like this. I'm not sure, but I'm just imagining. Maybe it'll look like this. Okay? So what can you say about when x goes to minus 3 from the left? This is the odd function. That means it's symmetric with respect to the origin. Any point here, you rotate 180 degrees about the origin, it's still on the graph, all right? That's why your picture looks like this. Then you can say the left side limit of negative 3. See, your y approaches negative 4. That's why we choose B, negative 4.
So what if it was an even function?
Oh, that's a good question. So if we have an even function, then mirror image. This is negative 3. Your mirror image, see this point, get mapped to this point. You have a picture like this. So what do you say? The left side limit is 4. Right, everybody? The left side limit is 4. If I ask you, what is the right side limit? What do you say? Do you know anything about the right side limit? No. So you can say there's no enough information to tell what the right side limit is.
So is it ever with respect to the x-axis?
Sorry, what did you say?
So like you say odd is the origin.
Yeah, odd is the origin. Even is the y-axis.
So what is the x-axis?
We don't have a name for it. Even because if you symmetric with respect to the x-axis, if you are symmetric with respect to the x-axis, for example, this is not a function. Remember, a function must pass through the vertical line test. This is not even a function. So you cannot say even or odd function. This is not a function. That's why they only say even function. This is the odd function. And this is a even function symmetry with respect to the y-axis. Yeah, so either y-axis or the origin for even and odd function. Yeah, good questions. Very good. Any other questions? Yeah. Yes?
So say if it was positive 3.
Positive 3.
Going from the right
Going
down
from
to 4.
Like this?
Yeah.
Yeah, this is given.
Okay.
This is given.
Okay.
Right. Yeah. Because of this information, we draw this picture. Okay. Yes. All right. Good. Okay. So very good. Let's continue on the new stuff. Okay. All right. So last time we talked about the power rule and the exponential function. The exponential function, the derivative is itself. This is so special, right? Yeah, because usually a function, the derivative will be different. But e to the x is so special, the derivative is itself. There is another function, the derivative is itself, which is the constant function 0. Because 0 is a constant, the derivative is also 0. So the constant function 0 and the e to the x, they are the only two functions that have the derivative being the same as the function.
And the derivative of a number is 0.
The derivative of a number, yeah, it's a constant function. It's the x-axis. So every point, the slope is 0 because it's a constant function. Yeah, the slope is 0. So the function and the derivative is the same. It's the x-axis. Okay. Good. And let's continue. Example 2. Find the equation of the tangent line at the point 0 and negative 1/2. And last time we find the derivative, right? The derivative of 2x is 2 because it's linear term, right? So linear term, the derivative is just a coefficient of it. Okay, so that's 2. And then you can think of this as 1/2 times e to the x. When you take the derivative, the minus 1/2 stays here. Constant multiple just stays here. And then the derivative of e to the x is e to the x. That's why we still have e to the x here. Typical mistakes. Sometimes students get confused with the power rule and the exponential function. They thought the derivative is e to the x minus 1. No, don't do that. It's the same function, e to the x. You don't subtract 1 on the exponent. Is that clear, everybody? Mm-hmm. Yeah, be careful. So this is the derivative, and we want to find the tangent line. So m tangent is the derivative. We plug in 0. Yes. So we get 2 minus 1/2 e to the 0. What is e to the 0? 1. Good. So 2 minus 1/2 is 1.5, which is 3/2. Yes. Good. This is the m tangent. Then what is the tangent line equation? Poincare form? When? Y minus y1 is, what's the point? Yeah, negative 1/2 equals the slope, which is 3/2 times x. Yeah, x, because the x coordinate of the point is 0. Good. Oh, do you see we get y plus 1/2 is 3/2x? Yeah, always solve for y. So we subtract 1/2, we get y equals 3/2 x minus 1/2. So far, so good, everybody? So this is the tangent line, okay? And let's keep going. Part B. Find the points on the graph where the tangent line is horizontal. So part A and part B, like they're asking two different directions. Okay, so let's say this might not be the correct graph. I'm just making it as an example. So part A is I give you at any point, and then you find the tangent line at that point. This is part A. Okay, part B is I want to know where the point the tangent line is horizontal. Well, horizontal means what? Your slope is 0. Do you agree? You want to find the x coordinate such that your slope is 0 at those points. So the slope is the derivative, right? So we set the derivative equal to 0. Horizontal, slope is 0. Okay? Yeah, so we set the derivative, which is 2 minus 1/2 e to the x, set it equal to 0. Because horizontal tangent line, it means the slope is 0. Okay? And solve for x. Ooh, this is equation involving exponential expression, right? We solve for x. We want to isolate the exponential term. Yes, everybody? So we subtract 2 on both sides. We get minus 1/2 e to the x is -2. Yes, everybody? And how do you get rid of the minus 1/2? You plus it, or you divide it by it, or you multiply by it. Multiply by the reciprocal, which is -2. Right, everybody? Multiply by the reciprocal. Then we get e to the x. What is -2 times -2? 4. Yes. What is x? Yeah, we apply ln on both sides. ln and e, they are inverse functions, so they cancel. We get ln of 4. And we're not done, because the problem said find the point. This is an x value. A point should be an ordered pair. It has x value, it has the y value. Okay, everybody? So if the problem says find the x value where you have the horizontal tangent line, then you can stop here. But it said find the point.
So would you plug in the ln for the x?
Yeah, exactly.
Whatever it equals, that's your y point.
Exactly, very good. So yes, so we plug in ln4 in the function f. So we get 2x, x is ln4, minus e to the ln4 over 2. Oh, what is e to the ln4? 4, yes, e and ln, they are inverse functions, right? So this is 4. 4 over 2 is 2. Ooh, we get 2, ln4 minus 2. Yes. So the point is the x coordinate is ln4. The y coordinate is 2 ln4 minus 2. So we have 1 point. So far, so good, everybody? Okay, so we keep going. Oh, sure. That like the part B?
Yeah.
Okay. So next example, you're given the function 2x cubed minus 15x squared plus 24x. And you want to find the x values. The tangent line has a slope of 6. Okay? So slope is the derivative, right? We we take the derivative. Okay, derivative. What's the derivative of the first term? Blaine?
6x.
Yes. What's the derivative of the second term? Will? Yeah, minus 30x. Is everybody okay with this? Do you want to do it slowly, like 15 times 2 times x to the 2 minus 1? Everybody okay with that? Okay. And next, Dylan, what's the derivative of 24x? 24. Yes. This is the derivative. It represents the slope of the tangent line. And we want to set this equals 6. Okay, so slope is 6. So here, make sure you understand 3 concepts. Okay, the 3 concepts are, is it an x value? Is it a y value? Is it the slope? Okay, x value is the x coordinate. Y value is actually the function f of x. Okay, everybody? It's f of x. The slope is the derivative. Okay? So slope is 6. It's the derivative. You set the derivative equals 6. Sometimes students might get confused and put the 6 for the x. No. Slope. This is slope. Okay? X. X is where the point located on the x-axis. Okay? But slope is really the slope of the tangent line. It means different. So be careful. Your slope is 6. Don't put the 6 for x. Okay? Your x is not 6. All right. So we get a quadratic equation. How about let's move all the terms to the left-hand side, right? So we get 6x squared minus 30x. What's 24 minus 6? 18, right? 18. So plus 18 equal to 0. Can we simplify this? We can factor, or you can both sides divided by the common factor, which is 6. Okay, Paige, if we divided both sides by 6, what do you get? The first term divided by 6? X squared. And the second term divided by 6, what do you get? Minus 5x. And then the last term? 3, yes. Good. So we get a quadratic equation. Remember 2 methods? We either factor it or use the quadratic formula. Okay, so can we factor, like 3 is like 1 and 3. 1 and 3 give you 4 or minus 4. It won't give you 5, right? So we must use the quadratic formula. Let's see, Mackenzie, what is the quadratic formula? Negative b. And your b is -5. And then plus or minus square root of b squared. So -5 squared. And then minus 4. A is 1. C is 3. All over 2a. And a is 1. Is everybody okay with the quadratic formula? Okay. Minus -5 become 5. What's -5 squared? 25. 4 times 3? 12 over 2. Oh, what is 25 minus 12? 13, and then over 2. And that's it. Because this problem, it just asks us to find the x values. It's not asking us to find the points. So finding the x values is enough. Okay? So if we want to draw the picture, this is like we have a function like this, and we want to know if we have the slope is 6, and you want to find what is the x coordinates. This is what it means. Yes. Oh, do you mean you want to plug it into the calculator? For me, I think it's very clear that here the two roots because it's already simplified. If you give me this, I'm not clear what it is. But here is already simplified, so you can leave it like that. Yeah. If you have time, you can put this in your calculator. Then you can know where it located on the real number line. Okay, that's example 3. Now higher order derivative. So if f is a differentiable function, then the derivative is also a function. So the derivative might have derivative on its own, right? So we can denote the derivative of the derivative be the second derivative. Okay, so 1 prime is first derivative. The second prime is the second derivative. So this is this notation means the same thing. So second derivative, or you put a parenthesis around the 2. If you don't put parentheses, it means square. Okay, it's f times f. But with the parentheses, it means the second derivative. So it's the derivative of the first derivative. And this is the notation because this is, maybe I should write it here. So the recording, you can see it. So d dx, the derivative of the first derivative. Yeah, do the process again to find the next one. Exactly. Yeah, very good. So yeah, that's because of this notation. Do you see we have 2d multiplied together? Looks like that. So that's why it's d squared. The denominator, do you see we have 2 copy of dx multiplied together? Looks like that. So that's why we have dx squared. That's why we get this notation. And so similarly here, the n derivative is just you put the parentheses around the n. Usually the second derivative we use double prime, the third derivative you use prime, 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 and then the fourth derivative you don't use the prime anymore because it's too much. Okay, just put the fourth derivative, 4 inside the parentheses. Okay, so example 4. Find the third derivative of the following function. Okay, Gabby. So what is the first derivative? What's the derivative of 3x to the 6? Yes. What's the derivative of negative 27x? Thank you. Dong Jae, what's the derivative of the next term? This one is harder. We can do it slowly. So where do you put the 5? Stay here, right? And then you multiply by negative 2 over 3 times x to the... Yes. And what is 5 times this guy? Negative 10 over 3. And negative 2/3 minus 1 is? Yeah, very good. And what's the derivative of 2 times e to the x? Yeah, 2 times e to the x. The derivative is itself. Okay, everybody? Yes, the derivative of e to the x is itself. Yes, right. Oh, okay. So yet later on, we have something more fun. If you have e to the kx derivative, it will be k times e to the kx. So if you only have x, then it's the same. But if you have something times x in the exponent, you actually multiply that thing down in front. Yes, good. Okay, next. The second derivative. Joseph, what's the derivative of 18x of f? 18 times 5. What's 18 times 5? 90. X to the 4. What's the derivative of minus 27? And it's a constant term, so the derivative is, think about a constant function. What's the slope? 0. Yes. The constant term, the derivative is 0. Okay, so, and the next term, Layla, what's the derivative of the next term? And then x to the? Yes. And what's the derivative of 2 times e to the x? Yes. Oh, can you also tell me what this term is? Plus or minus? Plus, and then? Yeah, 50 over 9. X to the negative 1/3, right? Plus 2 times e to the x. Okay. Third derivative, so we need one more. Okay. Wayne, what's the derivative of 90x to the 4th? Yes. Can you also tell me the next number? Yes. Is everybody okay with that? When we multiply 50 times 8 is 400. 3 times 9 is 27. And x to the? 12. So what's 8 plus? Yeah, 11 over 3, yes. And plus? To the x, yes. So this is a final answer. So you just keep taking the derivative. So I strongly recommend you make it into the standard form before you continue. Okay? Especially when you see some x powers in the denominator, make it into the standard form first. Okay, so example 5. Wow, today we should finish 4.2, but we're still in 4.1. It's okay, we catch up later. Find the values of x so that the slope of the curve is 2. So the slope, what's the slope? The derivative. Okay, the derivative will? Yes. And that's it, right? The derivative of 5 is 0. So we want to have the slope. So set this guy equal to 2. So be careful. Don't plug in x is 2. X is not 2. They tell you the slope is 2 and you want to find the x. Oh, how do you find the x, Dylan? Yeah, move the 6 over. Then you get 2x equals 8. Then what is x? 4. And part A, we only need to find the x value. It's not asking us to find the point. So this is good. We don't need to plug in the line. Part B, find the tangent line and the normal line at x equals 1. Yeah, so this is the place you see normal line. Tangent line at x equals 1. What is the slope of the tangent line? Page? The slope is the derivative, right? We plug in x is 1. Okay. And what is the derivative? When you plug in x is 1, what do you get? Negative. So 2 minus 6, right? Negative 4. This is the M tangent, right, everybody? And we have a slope. We also need to find the point. We know the x coordinate is 1. How about the y coordinate? Mackenzie, what is the y coordinate? So we put 1 into the original function. So what do we get? See, here. So 1 squared minus plus 5. Yes, what is that? Oh, how nice. It's 0. So what is the Poincare form? Gabby, y minus 0 equals, the slope is 4 or negative 4? Yeah, negative 4. Times x minus 1. Oh, you see? We got y equals minus 4x. And when you distribute, what happened? Plus 4. So this is the tangent line. Is that okay, everybody? Don J, what is M normal? Yeah, very good. Negative reciprocal. Right, everybody? Then, Joseph, what's your Poincare form now? Equals? Yes. So y equals, when you distribute, what do you get? 1 over 4 and minus, right, 1 over 4. This is the normal line. Is that okay, everybody? Yeah. So if you want to draw the picture, this is tangent line and normal line is right there. So it's perpendicular to the tangent line at that point. And so we finished 4.1. We have exam on Friday, so come here earlier. You can also stay longer if you want for the exam. And then next week, you print out 4.2 worksheets. Okay, so print out 4.2 and yes, applications rate of change. Okay. All right. Have a nice day. If you have questions, feel free to ask me. You can come to my office hours or you can email me. Sometimes I can meet you in the evening. We can all go to TED Live and meet. Okay. Bye.